I'm Matt Scher with InSofast's. I have a background in construction management, large-scale commercial projects. In my 4 years in the field, I put $1.8 billion worth of projects under my belt. That was in Denver, Colorado, and I decided I needed a change of pace, so I started working for the family business, which is InSofast's. And I basically grew up around the product, so I knew just about everything there is to know about it already, so it just made a good fit. And yeah, so our exterior wall insulation with the InSofast's panels. InSofast's panels are an EPS insulation panel with built-in rain screen and furring. Here is a detail of what that looks like. Can you see my cursor?
Yeah.
Okay. So this black thing that's embedded in there is our built-in stud. It can be screwed with standard construction screws. They're actually engineered so you don't need structural screws at all to the framing. And it also has a proprietary glue strip on the back that allows you to attach with construction adhesive if you're going to concrete. So later in this presentation, I'll get into the basements. But so you can see there's grooves on the front and the back of the panel. There's little grooves on the back. Those are to allow water to drain out of the wall, and it will, no matter where that wall gets in, say you have an outside window and it sucks under the sill of the window, it will be able to drain even if it gets behind the insulation. Water won't get held in tension back there. And then these come in 2 foot by 4 foot panels that just stack together like Legos. It ends up looking kind of like an ICF. So some of the benefits of the panels on the exterior is they're actually breathable. So our panels range from 4 to about 3 perms, depending on the thicknesses. And that will allow outward drying. So if you get moisture inside your wall, it could still dry to the outside, unlike most conventional foam boards on the market. And then that double rain screen allows that drainage anywhere in the wall. It's installed with the inexpensive construction screws. You're not spending $1, $2 a piece on structural screws like you have to do with a lot of rigid foam applications or rock wool board. The built-in furring allows you to attach siding directly to the insulation panels. You can do this with a nail gun or with screws. And then the tongue and groove design does not require tape at all, so it saves a lot of taping. And it's going to be available in R8.5, R10.5, and R15.9. Someone have a question?
Yeah, how thick are the panels?
So the R8.5 is 2 inches, the 10.5 is 2.5, and the 3 3/3, the R15.9. In basements, you can see we're attaching with construction adhesive, and the built-in stud takes the place of your framing. Strength-wise, it's very comparable to a light gauge steel stud. You're just going to need to use coarse thread screws. You can use trim nails for your trim as well. And then it has drainage on the back side that would be against the basement wall. So if you get moisture infiltration through the wall, you're actually going to be able to drain it. And if you're expecting it, you can even put in a French drain. Otherwise, if you don't have the French drain, what it'll do is it'll very much limit the damage that will be caused by water coming through your wall. So I already touched on the drainage channel. So electrical raceways, I'm going to go back to kind of show you. This is this is the wrong panel in that detail. I'm sorry. So most of our panels have electrical raceways that allow you to pull wire through the panels. They're basically little channels that are molded into the foam. And to access the raceways, you just use, depending on the product, either a snap-off utility knife or a hot knife to expose the raceway. And there's a number of different ways you can attach electrical boxes, either to the panel, the studs of the panel, or to the wall. So it's installed with construction adhesive, very, very quick install. We're talking an average 1,500 square foot basement. 2 guys can do that in under a day, typically. And then the built-in framing allows interior finishes to be installed. It can even support the weight of cabinets, shelving, or TVs. And again, it's available in the same thicknesses and R values. So exterior walls and roofs with X brackets. So this is our newest product. It came out last year. It's basically a thermally broken standoff for use with closed cell spray foam or blown insulation. You can see on this house, they're doing a layer of closed cell spray foam continuously on the exterior of the home. And it's kind of hard to see in this picture, but they also did the roof as well. And one of the cool things about using the spray foam continuously, you're going to get a lot more performance out of it. And you're also going to have a more continuous air and vapor barrier with the closed cell spray foam. Because when spray foam has failures, 9 times out of 10, it's going to be between wood and the spray foam. This is basically eliminating those joints. Spray foam sticks really good to itself, so we have not had a single project where the foam cracked or anything. So it's, I believe it's a much better way to use spray foam. And also you don't have all the framing connections that you either have to caulk or will be air leak through the wall, like the sill plates and stuff like that. So this is, you had a question?
Yeah. So I was looking on your website and there was a demonstration using a Batt insulation with the X bracket.
Yeah, that's my next slide, I believe.
Okay, great.
It's coming up pretty quick here. So you can see these are the X brackets inside the wall. These can be spaced up to 4 feet on center vertically and up to 24 on center horizontally. And you can also invert that spacing to do horizontal furring strips. So basically the spray foam is sprayed over the sheathing. We have had people like Matt Reisinger actually did it wasn't his house, but it was Build Show Live demo house. He used this system, but he decided to put it over zip just to have basically a backup air barrier below the foam. And then you vent with the core vent at the bottom. Just have a treated bottom plate to retain the insulation. You can easily overlap the sill plate connection, which is usually the leakiest spot on the wall. And then there's also a lot of room for air to ventilate the wall. So when the sun starts beating down on the siding, it's going to cause the air to rise and dry out everything in this wall. And typically we recommend the spray foam be held back from the furring strips, as you can see here, to allow air to move in both directions inside the wall. So the benefits of this, the closed cell spray foam can act as a continuous air vapor, water, and thermal control layer all in one step. So you're eliminating a lot of repetitive steps in using closed cell spray foam in that manner. And then it has that cross-ventilated rain screen. There's no seams or gaps that could open up for water to penetrate the wall. You can actually get passive house or near passive house levels of air sealing with spray foam. Typically, people in the passive house world don't like spray foam because there's been studies that show over the years the connections between the wood studs and the foam start to fail. But when you eliminate those connections, you eliminate a lot of that risk. So extremely high R values per inch and upwards of 7 per inch, depending on the manufacturer. It's usually 6.5 to 7. And it's available in 2.5, 3 3/4, 5.5, 7.5, or 9.5 inches, just to give options on what depth of insulation you're going for. And the larger sizes are actually going to be ideal for net and blow applications. So instead of framing up Larson trusses, you can use the X brackets, put a net on, blow it full of insulation, and cover it with a WRB. So here's our Batt brackets. These are coming out in January. Again, it's a thermally broken standoff, but this time it's designed for Batt insulation. You can kind of see how it's got kind of like an X shape behind this front face that allows the corner of the batts to tuck in snugly to the bracket. So this is what the detail looks like. You're actually going to be installing over an air barrier, and then technically that air barrier could be on the inside of the wall, but air barriers on the outside of the wall just work a lot better. And that doesn't have to be zip. That could very well be air barrier wrap that would typically be used on the inside. And then you're going on with Batt insulation. You're going to want to steer towards the higher density batts. Rockwool Comfort Batt works great. Other ones like wood fiber, denim, sheep's wool, the stuff that's got shape and some level of rigidity works great with this. And then another thing to note is you're actually going to be using steel stud batts. And the reason for that is they're not, steel stud batts are designed to fill the full 16 or 24 inches because it kind of goes inside the stud, versus the standard batts that are designed to fill the 14.5 or 22.5 space between the studs. So it allows you to get full coverage. And then you're just going on with a vapor permeable WRB. And the nice thing about this is you're only putting a hole through every 4 feet. You're not poking thousands of holes through it with attaching your siding. And then it also gives that space for ventilation. This can also wrap up on top of the roof just like the X brackets can. So Batt insulation is much less expensive, especially when you start comparing it to products like Comfort Board. Comfort Batt compared to the Comfort Board is about a third to a quarter of the price, just R value to R value. And it allows you to very easily add more insulation than you would typically add. And then again, it has the ventilated rain screen, and that the batts in this assembly are going to have a very, very high drying potential because you have ventilation directly on the other side of a membrane that's probably 20 to 30 perms. it's going to be able to dry those bats out much better than if you had water penetration inside your wall cavity itself. If you get water, bulk water in there, it will very quickly dry out. And then the bats are size, or the brackets are sized for compatibility with standard bat thicknesses. And it's truly continuous insulation with bats. Another benefit to this is a large amount of noise reduction. You can't get much better than bats for noise reduction. And these are available in 3.5, 5.5, and 7.25. If we were putting this in terms of rock wool, that would be R15, R23, or R30. Now that I've covered our projects, I just wanted to speak about some building science topics because that is the purpose of this group. And I decided to go with avoiding moisture issues with insulation retrofits. A large number of our projects are insulation retrofits, and I have worked with NYSERDA, I've worked with University of Minnesota, or South Dakota State University, and other organizations in Chicago and whatnot. And the goal of all of these studies that these universities and programs are doing is retrofitting inner city housing, bringing the existing housing stock par with modern homes. So why do old homes usually not have widespread moisture issues? So the older homes are designed to be very breathable. The vapor barriers were not common until the 60s, and the walls could very easily dry in both directions. Old houses, the walls leak quite a bit, but the walls are so permeable that if there is moisture issues, it's going to be very localized to, say, right below the window or next to the door or the sill plate in this one part of the wall where the siding was leaking. So older homes and most modern homes have very poor air barriers as well, and that allows a lot of airflow through the walls, which aids in drying, especially in the summer, not so much in the winter because you can get a little condensation through there. But there's just so little insulation in the wall that condensation really wasn't an issue until we started building with more insulation. And in older homes, the moisture issues are typically localized, and they're either caused by moisture infiltration and water leaks from plumbing or elevated humidity in basements and crawl spaces, attics, where they have either ground moisture or rainwater penetrating in some way. So there's basically 4 ways how moisture can enter the home. Water infiltration, this would be bulk water from rain or snow, or groundwater. Water leaks, which would be plumbing leaks. Both of those are typically going to be localized to a certain area. And then humidity buildup, it could be one part of the house or it could be the whole house. This is from occupation, outside humidity, or ground moisture. And then condensation, which when that happens, it's typically going to be a widespread issue that affects the majority of the house when hot, humid air leaks through walls during cold weather and deposits moisture when it hits the dew point. So consequences of mold, I'm sure you guys already know this, but consequences of moisture are going to be mold, rot, pest infestation. Most pests will actually are going to gravitate towards moisture. I read an article by Joe Stiebrick not too long ago. He had this home that he covered in I think it was like 10 or 12 inches of EPS foam, and he had major carpentry issues. So Joe Stiebrick, being the kind of crazy guy that he did, ripped all the siding off, all the insulation off, to try to figure out what was going on. He ended up finding out that he had a reverse flashing that he accidentally had at a connection between a roof and the wall, and that ended up dumping moisture. The ants had a huge burrow in that area, but nowhere else in that home where there wasn't moisture present were there ant colonies. And the same goes for most termites as well. I don't know if you have many termites in your area or not. They gravitate towards moist wood in most cases. There's some species that will go for the dry stuff, but most of them will go towards moisture. Retrofitting exterior walls, it's very, very important to know what's inside your existing walls. Pay close attention to vapor permeability and address any moisture issues, because retrofitting a house with moisture issues is going to compound those issues. Vapor permeability, if the house is completely vapor open, say it's a 1920s home, very good drying to both sides of the walls, you can pretty much go with any type of insulation and not worry about trapping moisture. But if you have, say, the 80s house that had the 6 mil poly vapor barrier, it's going to, if you go and put, say, XPS foam or polyiso on the outside, something that's going to become a vapor barrier, you're going to end up with a double vapor barrier, and you're going to end up with a wet diaper effect. Moisture through air infiltration, condensation, typically is how it happens, is going to build up inside the wall and not really have a way out. So that's where you end up with major mold issues, major structural damage due to rotting. Only one vapor barrier in a wall is very, very important. And the best place to put it is outside of the sheathing. I'm sure most of you are familiar with Joe Stiebrick's perfect wall, where he has no cavity insulation, vapor and WRB barrier, and then insulation in that order. It's going to be more effective at blocking airflow, and it's going to allow the moisture from inside to dry inside and the moisture from outside to dry outside. There is another school of thought where you don't need a vapor barrier. Works great in climates like yours that aren't super humid, but not the greatest idea if you're in Alabama like where I am. And then another thing is know your dew point. Most board insulation will limit the outward drying, so making that condensation is very, very dangerous. So this is a tool. This is the construction instruction condensation calculator. This is one of my favorite tools in the insulation world. So it allows you to pick your location. So I picked your location, Bozeman, Montana. And then it allows you to put in what you have in your walls. Typically, that if you're doing an insulation retrofit, it's probably going to be R13 or less. And then you put in how much exterior insulation you want to put in. And then it will give you a chart based on what you entered. So this blue line is the average outdoor temperature in your location throughout the year. This green line is the calculated temperature of your sheathing throughout the year. So you can see this green line, and then this red line is the dew point of average temperature air inside a house. So you can see the green line does not dip below the dew point, so any condensation that's going to happen is going to happen outside of the sheathing, and that's where you want it. That's outside of your moisture control layers. And if you have something that's not vapor permeable, such as closed cell spray foam or foam board, it's not even going to be able to condense at all because it won't be able to get to far deep enough into the insulation where it would condense. So where you could run into problems is if this green line drops below the red line. That means that any air leaking outside through your walls is going to be depositing condensation inside the walls during that period of time. Does that make sense to all of you?
Yeah.
Okay. So this is an example of what not to do. So a very common thing with insulation retrofits, a lot of siding guys like to do it as an upsell. They add R5 or R6 continuous insulation board. XPS or polyiso are the most common, or in some markets even faced EPS. But so you have the same R13, you're adding R5. Now this green line is dipping below the red line. So for 2 months out of the year, you're going to get condensation building up inside your walls, and having a impermeable foam board on the outside is going to really hinder the outward drying of the wall assembly, so it can only really dry inside. And if you have interior vapor barrier, you're really going to run into problems. So as a rule, I do not ever recommend R5 to R6 foam board for exterior insulation, especially if you're in a cold climate. You can get away with it in southern climates, but not where you are. Retrofitting vented attics is kind of difficult. Sure, you can go and blow more insulation inside of there, but the thicker the insulation is, the harder it will be to dry out any condensation. And ceilings are, generally speaking, pretty leaky unless you're doing it like Steve Basic does it or something. So you're really going to want to dig down in that insulation, find all of your top plates, seal those as best you can with spray foam or caulk, go over any lights or electrical boxes with an air seal box like this, and seal it in place with caulk or foam. It is very labor intensive, but the more insulation you have, the more risk of building up condensation, because it's harder to dry through this much insulation versus the 8 inches that's probably in the house already. And then moving on to unvented attics and vaulted ceilings, this is going to behave very much like a wall. It's just code requires a lot more insulation. I personally don't believe that attics or that vaulted ceilings or unvented attics need the code required amounts of insulation, but because really you're taking a wall and putting it on the roof, it doesn't get that much more exposure. Sure, it gets heat from the sun, but your walls get that too. So you get a lot more out of your insulation if you're able to do it in a continuous manner. So basically treat your roof like it's a wall. Continuous insulation on the top of the roof is ideal. For the same reason, continuous insulation on the outside of the wall is ideal. And then you're still going to want to pay attention to the dew points. This one, so you have R30 cavity insulation, you would need to put R20 continuous insulation on top to get out of the dew point risk. And then avoid spray foam on the underside of the roof deck. I'm sure y'all have mixed opinions on this, but I've seen time and time again where foam on the underside of the roof deck holds moisture, hides the issue until it becomes a major structural issue. But if you move that spray foam to the outside above the roof deck, like you would with our X brackets, it's actually going to provide a protective layer to prevent moisture from getting to your roof framing. It'll basically be almost like a second roof below your roof that will shed moisture off, and it would drain either through your wall rain screen or through your soffit vents. So basements, retrofitting with insulation. I'm sorry, you were breaking up a little bit.
I have a question on insulating roofs. Can
Yeah.
you do that with the product that's meant for bats on the roof?
Yes,
And
absolutely.
then do you recommend the same WRV on the outside of that, or is there a different product that you recommend for roofs?
So we have done mock-ups both ways using a WRB over top of the insulation, but in reality, when you're putting bats on, it's a very similar situation. You have ventilation above it. It's going to behave very similar to a vented attic with blown insulation. So yes, a WRB can add extra protection from roof leaks. It'll allow water to shed off. But it's not really a requirement like it is on the wall, because it is behaving very much like that vented attic.
So you're saying you could just do the bath and then, like a furring strip that you would attach your roofing to if you were doing maybe a metal roof, or
Yes.
so plywood over it?
Yep. Yeah. Or if you want to add an extra layer of protection, you very well can put on a WRB. Just make sure it's vapor permeable is the big thing there. So, adding humidity in homes, when you start doing insulation retrofits, more often than not, you're going to reduce the breathability of the home itself. So you're going to have a better air seal, which is going to build up more humidity in the home, and you might be switching to a more efficient HVAC unit that is less effective at removing moisture. So dehumidifiers are a really good idea if you are going to be retrofitting a home, or even with new construction. If you're building tight, dehumidifiers are a must. Installing it in places like basements, crawl space, attics even, but if you're doing a localized one, otherwise one that's tied into the HVAC, will get the whole house. And then vapor barriers, don't use a cheap vapor barrier. I was actually doing a crawl space today. I took a day off to help a buddy, and I don't do anything but a 20 mil in the crawl space. Anything less than that is just going to get holes poked in it, and it's not going to last. And then fresh air intake can be a way to combat humidity. ERVs and HRVs, more so in dry climates, do remove humidity from the home. And that's because, ERVs and HRVs, most of them do transfer, they put pretty close to the same amount of humidity back into the house as it takes out. So it's designed to be balanced to not affect humidity. But when you're in a drier climate, it's actually going to pull out more because there's a bigger differential in humidity between the inside and the outside. And the reason why it's not it puts in exactly what it takes out is because it's not 100% efficient. So there's some efficiency loss. So it will do something to remove humidity, but it won't, but really only if you're in a dry climate. So do you guys have any questions?
I have a comment for
Yeah.
some additional things you could add to your benefits page on the extract for the Batt decision. A real challenge that we have here is getting insulation board products that aren't foam, and we try to avoid foam in our projects as much as possible because we're focused on embodied carbon as well as energy efficiency. So,
Yeah.
so I'm excited to have an option that allows us to use parts we can actually get here.
Yep.
What's the other one I was going to say? I guess that was the main one. Well, and just being able to use lower embodied carbon products.
Yeah.
We did talk about that in the presentation, but it's becoming more and more something that people are focused on. So.
Yeah, absolutely. I do have one more thing that I wanted to do. Let me go to the condensation calculator and just do a quick demo.
This is app construction instruction for iPhone.
Mm-hmm.
Where do you get to that within the app?
I didn't find it in the app. I'm sure it's on the app somewhere.
Whenever I find it, I usually just search construction instruction, condensation calculator. I don't know how you'd get to that from their homepage. So, do one of you want to throw out some numbers that you'd like to see in your area?
Well, you could put in whatever our current code requirement is, just R21 walls, nothing on the exterior.
Yeah, let's do that. Montana, there it is. So 21 with 0 on the outside. So this is what it looks like from basically mid-October to mid-March. If you have air leaking through your walls, it's going to deposit moisture.
Totally, yeah.
Yep.
So this is something that, obviously in IUCC, for our climate zone, we should be, having exterior insulation, and it's always something that gets amended out. This is a really clear visual demonstration of what we shouldn't be doing, what we're currently doing, and putting, a poly vapor barrier on the interior wall, which is never perfect, which is how they're drawn, but they're never that way in the real world. And so this is the exposure and the problem that we end up with. So I was, while you were presenting, I was looking, I was like, all right, what's the current code? What does IAC actually say we should be doing, right? And for our climate zone for 2021, we should be at 13 and 10, 13 on the interior and 10 on the exterior, right?
Yeah. And then the other thing that you mentioned, the poly, I would, if you're not doing continuous insulation on the exterior, you really, really should have a smart vapor retarder that will allow the wall to dry in both directions, because there is a 100% chance that any air leaking out, unless you have an abnormally warm day, between mid-October and mid-March, is going to condense inside your wall somewhere. So it's really important to have an outlet to that moisture, and typically homes are being sheathed with OSB, which is typically around 3 perms, which is very close to a vapor barrier. So yeah, if you wanted to keep the 21 and add continuous insulation, I would guess you'd need about 15, not 51, 15. Let's see. Yeah, 15, maybe 12. Yeah, 12 looks like about the bare minimum if you have R21 to get you out of that condensation range.
But if you have a smart vapor retarder behind the sheetrock on the inside, you wouldn't get that moisture in the walls, right?
Well,
If it was installed.
is your
Well, it doesn't even perfect.
is your
It's-
smart vapor retarder going to provide a 100% air seal after you install your drywall, poke hundreds of holes through it? I would argue probably not. So any air that leaks through the walls is going to condense inside the walls.
Yeah, I would agree
That's
that
just-
a pinhole leak in a wall will transport way more moisture than bulk vapor drive through a wall. But your general vapor retarder doesn't have to be installed perfectly to be effective, is what I understand.
Well, it's effective against that bulk vapor drive. but
Yeah,
not
Which is
the
what
air-
majority of what he's talking about here.
Yeah, but
like
then
the-
what about the airborne?
Yeah, but as long as you have a good air barrier somewhere in that wall,
Yeah, but I think.
then it's not gonna dump tons of gallons of water in the wall. If
I
there's
think
no
that's,
air-
I think most people are installing the vapor barrier and being like, there's my air barrier done, don't you think?
Yes, they are.
Yeah,
If they're considering that their air barrier and they're not doing a good job, then yes, that could be a problem.
Yeah.
But still, you need a pretty good pathway through the wall to carry a bunch of water, is my understanding. Like, it has to be pretty darn leaky.
Yeah.
Condensation,
But
like.
pretty darn leaky, I would say, is 4 air changes per hour is pretty darn leaky.
Yeah, I mean, that's not how I built, but.
Yeah.
Present company excluded on.
right, exactly.
Yeah.
We are already.
We're perfect.
Let's say your WRB on the outside was your air barrier, then I think you could put up that smart vapor retarder on the inside and not have this
Yeah,
dew point issue. It wouldn't be a problem.
you would still maybe have the dew point and condensation, but you have a pathway for it to dry.
I mean, in a perfect world, if you had a membrane on both sides of your walls that was a vapor barrier, but it was perfect, both of them were a perfect air seal, you wouldn't have any issues whatsoever.
They both have to be a perfect air seal. As long as one is, it stops air.
Yeah, that is true.
So I'm saying if the outside is your perfect air barrier, that stops your airflow.
But most of well, yeah, I guess, then it's not flowing in.
And then your vapor retarder on the inside doesn't have to be like perfect. It's literally percentage of coverage that is stopping that percentage of vapor drive.
Right.
Because now you're trying to compress something.
Well, from inside to outside.
Yeah.
In the winter, here, yeah, this climate. But anyways, that's how I understand it. So I don't know that this applies to, it all depends on where how your air barrier is, if that's good, and if you have a vapor retarder. Like, this is, in my mind, assuming you don't have a good air barrier or any vapor retarder.
Yeah,
right?
but that's a fair assumption for 99% of.
Yeah.
Yeah.
Renovations, yeah.
Yeah,
Okay,
yeah.
a lot of attention to, like my house and your house, no vapor barrier, right?
Yeah.
Yeah.
What's the carry forward? Right.
Yeah.
Anyways, I just wanted to clarify.
I like that tool though, man. I think that's a good.
Yeah, it's cool.
Yeah,
You're showing us that.
Is there
I
any
use
way
it quite a bit.
for this?
The green line is assuming that's where your vapor retarder is.
The green line is actually your sheathing. So
Yeah.
if you have condensation, you really want it to be outside of your sheathing, or not at all. In a perfect world, not at all, but that would require a perfect air barrier, which is, I would argue that there's no such thing as a perfect air barrier. And it only takes one stud bay that's a little bit messed up to cause more mold issues in your wall.
Matthew, thank you for the time. I appreciate it. Thanks for showing us what InSofast does. Like those X brackets especially are really cool, I think, because it provides a lot of option.
Yeah.
Not that the other products aren't good for the purpose they're intended for, but I think the X bracket provides.
Yeah, I'm really excited about the Batt bracket coming out. That,
I have a question about that. We had looked into a similar, a product that kind of served a similar, purpose on the project, and that was also gonna have party board siding, concrete.
Cement fiber.
Thank you.
Yep.
And the party board, said that they couldn't, honor the warranty of the product if it was installed on the traffic.
over furring strips, you're saying?
Yeah, I guess.
It's probably the weight of the siding.
That's what I'm thinking.
It's already, it's
It's really heavy.
Yeah.
yeah.
And the X brackets, depending on the spacing, can support well over 200 pounds a square foot of wall area. So that's in our code compliance report. But yeah, as far as installing overfurring strips not being warranted by Hardy, I have heard that. But at the same time, every time I see, say, Matt Reisinger install the siding, almost always it's going to be overfurring strips, regardless of the type of siding.
Yeah, okay. We don't use it a lot, but in that project, it was sort of
Yeah.
they chose that over